So the heuristic question was not completed very well by a lot of students. Um, Specifically misunderstanding the point of the question and kind of like making mistakes about what a heuristic is, which was what was a key thing. If you remember, if you don't write accurately about what something is, then you will be kind of restricted down to low band. You might squeak into mid band if the rest of it is good, but you are running that risk of low band. So knowing exactly what a heuristic is. Now remember, when we talk about heuristics, we are talking about not that the program is easier to write, okay, because that's not true. For example, if you think about Dijkstra's algorithm and think about A star, well, Dijkstra's does not use a heuristic and A star does. A star is actually harder to implement than Dijkstra's because we have two sets we have to kind of manage. We have a heuristic function we have to develop, and that's going to be contextualized. So it depends on the scenario, it depends on which heuristic I use. Well, these are extra levels of complexity when I'm coding it, whilst Dijkstra is just Dijkstra's. It will work the same way every single time. So taking that in context, if you started writing about heuristics make your program easier to write, any kind of phrasing around the code, you automatically are not answering the question. You are making it inaccurate comments, and then obviously that then implies the rest of it will be wrong as well. So that's where a lot of the low bands came from. Secondly, heuristics are really focusing on time complexity. So when we're talking about a heuristic, what we are really trying to do is kind of like reduce the time complexity of the algorithm running and therefore make the program maybe more responsive, get that result faster. But obviously the trade-off between speed is accuracy. So if we kind of start to look at the mark scheme, you'll see that in the facts for knowledge and content, it reduces time taken to solve a problem. Now, when it says solve a problem, it doesn't mean write the code for it. It means when the code is running to solve the problem is given. Okay, it's I don't think it's particularly well worded, if I'm honest with you, but that's kind of what it means. As a general rule of thumb or educated guess, I don't particularly like that phrase. I prefer approximation, but rule of thumb can be used, I guess. What I prefer is the third comment where it says it finds a solution which is good enough or close to the best solution. Okay, so it's going to come up with a solution that works but isn't perfect. Okay, it's faster to process, it will have a better time complexity, but may not be accurate. Okay, if we start to look at the application, you can see straight away it's talking about time complexity because that's what the focus of this question really is. So reduce the time complexity as every possibility within the game does not need to be examined. So remember, the perfect solution would consider everything. If we maybe think about chess as another example, when you play chess and you're trying to do a perfect move, well, to do a perfect move, you probably want to consider almost every single possible move that could happen and to see whether you can win or not. So maybe like the minimax algorithm. That is computationally too expensive to do because there's an exceptionally large number of moves can be made at any given time, and if you kind of then played through that even with like 10-20 moves, that is computationally infeasible. So heuristics have to be used in order to make that work. In order to make a good heuristic, that there is skill and development, because if you choose a rubbish heuristic, then the result is also going to be heuristic rubbish as well. So there is this kind of skill to make sure that heuristic matches the context, and because heuristics are always context based, you have to implement the heuristic per implementation, per program you write. Okay, you can't just like use the same heuristic for everything because it doesn't work that way. And that comes back to that knowledge of what heuristic is. So coming back to my original argument on this one, revising over, make sure you really understand what heuristic is really important. Just as a side point as well, that is the key for every single long answer question. Okay, knowing the content deeply enough and well enough to be able to respond to a long answer question. Anyway, I've generated an answer from AI. So let's just kind of go through it and let's see how it matches up. So Heuristics are used in artificial intelligence to make decisions more efficient by reducing the time required to solve the problem. Okay, so that's that first bullet point straight away. They act as a rule of thumb or educated guess, allowing the algorithm to find a solution that's good enough rather than guaranteeing the best solution. For example, in the OCR, a heuristic is used to estimate the distance from the current node to the destination, helping prioritize the next step in pathfinding. Okay, so a little summary of A star because that kind of links in route finding. So that is kind of meeting the requirements of these first bullet points. It's given a kind of an overview of heuristics. I would preferred if it was talking about time complexity personally, but there you go. The main benefit of using heuristics is that they reduce time complexity. It's not necessary to examine every possible move within a game. This is especially useful when the number of possibilities is large. Heuristics allow the AI system to make decisions in scenarios where pre-programmed steps are not feasible. However, implementing effective heuristics requires skill, and poorly designed heuristics may lead to suboptimal solutions. Additionally, because heuristics aim for speed rather than accuracy, the solution they provide, such as shortest path, might not always be the most efficient or optimal. So notice that's kind of going through the benefits and drawbacks. The benefits, reduce time complexity. Drawbacks, it's hard to implement it. It is not always going to give you the best kind of solution. Then it's kind of got your AO2 here. Okay, so none of that is, it's kind of a little bit AO2y, but it's more linked in with the kind of second bullet point. So some application, but not all. In the concept of the computer game, heuristics are particularly suitable because games often involve complex, time-critical tasks. For instance, a computer-controlled character may need to decide quickly on the best path to take or the most advantageous move to make. In large-scale games, with multiple characters and interactive elements, heuristics help avoid excessive computational demands that could cause the game to slow down and crash. Furthermore, as games are not life-critical, a good enough answer is acceptable, and achieving perfection is not necessary. Okay, so you see here it's kind of linking in some of these points back to the game. So thinking about, well, okay, it's not going to give you an accurate solution, but it doesn't matter because it's a game and it's not critical. And you know, if the game is not perfect, who cares? You know, it's a computer game. You know, so there is that kind of now linking the point back to the question. Okay, it's absolutely okay for you to state a point and then put the link back to the question straight away. That's absolutely fine. You don't have to lay it out this way, but you must always mention it. And then overall, heuristics are suitable for algorithms in computer games as they balance efficiency with practicality. While they're not always produce the best solution, their ability to handle large-scale dynamic and time-critical tasks make them valuable in AI development. So, if we look at some of these key points, you've probably noticed this AI has just literally taken these mark scheme and written it into paragraphs. So it's quite clear this is going to be meeting the high band. Is it the best answer in the world? No, but it's meeting the high band. So hopefully that gives you an idea of what you should talk about. So to summarize, you'll make sure you're covering these main bullet points. You need to know exactly what a heuristic is and the key talking points about heuristics, and then link them back to the question. So if I've thinking about accuracy, for example, well, if I've not got an accurate solution, how important is that? That's your kind of evaluation, isn't it? If that makes sense, okay? So what is the knowledge? Okay, heuristics are accurate. Application, well, how does it link back to this question? And then as a disadvantage, as an example, and then obviously because it's not like critical in a game, then it doesn't really matter as much. Hopefully that made sense. Hopefully that was useful for you.